Hello 8th grade. Today we are going to be looking at how to simplify expressions with square roots and higher order roots. So we're looking at both square roots and higher order roots, and we'll kind of get into what that means later. We've talked about square roots a little bit already. Just in this example, we're going to look at the square root of 64. When we look at this, what we want to think is, of course, what times itself is 64. So we know that something times itself has to be 64. And just think about this a little bit. I hope you guys remember that 8 times 8 is 64. So our answer, the square root of 64, is going to be 8. Now, some of you might be thinking, wait a second, Mr. O'Connor. We can also get 64 by doing negative 8 times negative 8, which would be true, but we're going to say that the square root of 64 is going to be positive 8, just because the square root is always going to be positive. So the square root is always positive. Alright, we're going to move on just a little bit to some higher order roots. So sometimes we're going to see things like this, where instead of having a no number here, we're going to have like a 3. So let's look at the cube root of 64 is what this is called, or the third root. So the third root of 64. And what that's asking, instead of being the opposite of squaring something like our square root, it's the opposite of cubing something. So now we're asking what times itself times itself. So 3 of them is 64. So we have the 3 here, so we're going to have 3 of these. We're asking ourselves what times itself is 64. And when we do that, we can tell eventually, guess and check a little bit, we'll get to that the cube root of 64 is going to be equal to 4, because 4 times 4 times 4 is 64. A different way of looking at this would be to look at the cube root of 64, and then we can write 64 as 4 cubed. So if we have the cube root of 4 cubed, the cube root cancels out with the cube on the inside, so the cube root of 4 cubed would just be 4. So because the cube root is the opposite of cubing something, the cube root's the opposite of cubing something, that means if we do the cube root of a cube, they cancel each other out, and we just go back to the original problem. So now we're going to look at one other one, which would be the cube root of negative 8. And I hope you guys are thinking right now, no, we can't do the cube root of a negative because negatives can't be inside roots, which is absolutely true for square roots. We cannot take the square root of a negative. It's kind of like dividing by 0, just one of those things we cannot do. But if it's a cube root, we can. So we're asking ourselves what times itself is negative 8. So we have something times something times something equals negative 8. And for these odd numbers, if we end up with a negative, we're going to have a negative number. So 3 is an odd number, so if we end with a negative, we're going to have to start with a negative 2. And above that, we're asking what times itself is 8. So we have something times something times something is 8. And that's going to be 2. It's going to be 2 because 2 times 2 times 2 is 8. So we can say that negative 2 times negative 2 times negative 2 is going to be negative 8, which means that we are now looking at the cube root of negative 2 cubed, and just like it did before, the cube root cancels us out with the cube there, and we end up just with negative 2. Looking one more time, I want us to try the fourth root of negative 1. So if we see an even number here, that means we're going to have an even number of things multiplied. And if we have an even number of things multiplied, that means we can't end up with a negative. So if we have an even root, that means we can not have any negatives in it, so no negatives. That's like dividing by 0, and that is very, very bad. So bad right there. If we have any negatives inside an even root, we say that that is undefined. Our answer is undefined, or we can say there is no solution. Either way, just say that you can't do it, we're good to go. So if this right here is an even number, if that's even, and this is negative, then it's bad and we cannot find an answer. And 2, of course, is my favorite even number. So if we have the square root of a negative with a 2 here of like -4, let's say, we cannot do the square root of a negative, so we say there is no solution. I know that up until now, we've been working with things that just look kind of like this, with no number here. And no number means we assume 2. So no number means there's a 2 there. So if there's nothing there, just think square root. Nothing there means square root. So something I want to talk about now is a fractional exponent. This is one of those weird things that is something we use with exponents because it has to happen, but it's not really intuitive. So we talked about negative exponents earlier, and now we're going to put fractions in an exponent, which is really crazy. So what ends up happening for fractional exponents, let's put this up here, fractional exponents, is that we have the in root of something. So I'll just show you the generic way with variables in it first, and then we'll go back and we'll do it again with real numbers. So if I have the nth root of some number, that's going to be equal to x to the power of 1 over n. So with real numbers, what this looks like is if I have, let's use the 4th root of 16, that's going to be equal to 16 to the 1/4, and those are the same things. So these mean the same. It's just that on this side right here, we're putting the fraction in the exponent, and on this side right here, we're leaving it as the 4th root. So it's different ways to say the same thing. And I want us to think about, to see if it makes sense, we're going to use our power rule. So just quick review of the power rule. Our power rule says that if we have some number to a power, so let's do 2 cubed, and then we do that to a different power, like to the 4th, that's going to be equal to 2 to the power of 3 times 4. So that's saying that 2 to the 3rd to the 4th, if we have it set up like this, we are going to multiply. So if I have something down here that says I want to find the cube root of 27. The cube root of 27, I know that 27 is the same as 3 to the 3rd power. So 3 times 3 times 3 is 27. So I can now rewrite this as the cube root of 3 to the 3rd power. So 3 to the 27th equals the the cubic root of 27, the 3rd root of 27, is equal to the 3rd root of 3 to the 3rd power. So I'm going to rewrite this with my fractional exponent. So now I have 3 to the 3rd power, and what this is here, instead of doing the 3rd root, I'm going to do to the power of 1/3, because we can change this to an exponent by doing 1 over whatever the root is. So I have a 3 here, I put a 3 in the denominator. So I know that if I have the cube root of 3 cubed, we talked about those being opposites, these cancel out, and I should end up just getting 3. So if I look over here, I have 3 cubed to the 1/3, so I should end up with 3 to the power of 3 times 1/3. Then the question is, what is 3 times 1/3? 3 times 1/3 is 1, so I have 3 to the 1st power, and 3 to the 1st is 3. And because these two are the same, that means that it works. So it has to be this way to where our fractional exponents work out. So if I want to find, let's do 216 to the 1/3, 216 to the 1/3, what I'm going to say is that this is the same as the cube root of 216. I also know that 216 is 6 cubed. If you can't find that right away, guess a number and then go up and down from there. And I'm going to take the cube root of that. So the cube root of a number cubed, those would both cancel, and I would end up with that just being 6. So 216 to the 1/3 equals the cube root of 216 equals the cube root of 6 cubed, which then equals 6. So 6 would be my final answer there. And I would like you guys to try finding a couple of problems for me. So we're going to do 10,000 to the power of 1/4. And please find this. And I would also like to go back and just do a regular square root problem. And I would like you guys to try to find the square root of 9 for me. The square root of 9, and then the cube root of -27. So those three I would like you to do before class at the end of your notes, and just bring those in, and we should be good to go. I will see you guys in class.